All right, we are good to go, Tyler. Go ahead.
All right, so this is the second workshop on 3D printing. So this one's more focused on picking a printer and then using a slicer so you can actually start printing stuff. So to start with picking a printer, so you got a couple different options. You've got you got a lot of options nowadays. So for some examples, you can get the Colossal Mini and its clones like the FL Sun or a Delta. They're cheap. They have decent prints and they're customizable, which is super nice. However, they can be unreliable. They need complete assembly, and no two kits are totally the same. So you'll need to use resources like the internet to help you actually build it, and those typically run about $300. Then you've got the Prusa Mini. So it's got most of the Prusa features that are on its i3 on their i3 series. It's competitively priced for what it is. It's easy to assemble. It's just most of it comes pre-assembled. It's just a few bolts and some electronics. The manuals are very, very clear on how to do everything. It's also Wi-Fi enabled, which means you can send it files from your computer and you won't have to use an SD card or a USB drive. It actually also supports USB drives, which is super handy because not a lot of printers do that yet. Although some disadvantages are it's got a much smaller build plate than some printers that are in the same price range. And the filament runout sensor costs extra, which none of the other ones have it. So if you're comparing it against something that doesn't have a runout sensor, it doesn't really matter. And then it's a cantilever design, so it only has one Z-axis motor, which holds up the whole extruder assembly, which I've seen some people say they've had issues with it, but I've seen other people say it works perfectly fine, so your mileage may vary. Then you get to the Prusa i3 and other RepRap style printers. So these can be, they're cheap, they're reasonable quality. Most of them are open source and there's large communities built around them, so that makes them easier to mod. So like if you go out and buy something like an Ender 3, for example, which would be about $300, that particular printer has a massive community. If you want to put something on that printer, somebody has a guide on how to do it, and there'll be lots of people who are willing to help you with it. The same can be said for the mainline Prusa i3 ones. Massive community. Their support team is also very helpful for any issues you may have. Although some disadvantages are is that the clones do have a more widely varying quality. So like the Creality Ender 3 is, the instructions aren't great, but the printer itself is a very good machine. But something like the TiVo Tarantula, for example, which is supposed to be an identical clone of the Mark III, I've seen some people say they've had some issues with assembly and it not totally working exactly the way it's supposed to, although they were able to get it properly working. Then it kind of the more expensive, a fully built Mark III, which is the $1,300 point. It's $1,300. You can get a kit, which is only about $1,000. So this is typically where most people buy their 3D printers, is somewhere in the $300 to $1,000 range. Although you have some premium options like the MakerBot Replicator and the Replicator Plus. The MakerBots are pretty reliable. They got remote operation, so you can send and monitor parts remotely. They produce quality prints, just like almost all printers now. They're so good at making parts that look good compared to what they used to just a few years ago. It comes fully assembled, so you don't actually have to build anything, something that a lot of printers below that price range, you tend to have to build it yourself, which, depending on how much you like that stuff or don't like that stuff, may be a positive or a negative. It also allows the MakerBot slicer, which I'll get into what a slicer is and how to use one later. You can actually insert SolidWorks parts. so SolidWorks files, which makes it really easy if you're a team that uses SolidWorks. It makes it really easy to actually just go from model to print without having to save in a secondary format like a 3MF or an STL. Those are just file formats for saving 3D objects. So some disadvantages is that they're really expensive. Again, 3,000 Canadian dollars is a lot of money for a 3D printer. The stock maker bought hot end is also PLA only, which from a FRC standpoint will cover most of what you'll do. Although and the other hot ends are available for purchase if you wanted to print like PETG, which is just a different material. For example, you'd have to buy a different hot end, which is not really great because most of the other printers are able to print more than just one filament, although almost all printers nowadays print PLA at high quality because it's supposedly biodegradable in the right conditions, but it's made from renewable sources. So it's also very cheap. So it's 20 to 20, you can get as cheap as 15, so $15 to $50 a kilogram usually, which lasts quite a while. It's the most widely used, so unless you know you're going to use something other than PLA, that may not be a deal breaker. So where you can get some models, so I like to look for whatever parts it is I need. At least when I'm doing my own stuff, I like to see if someone else has done it before to see if I can maybe find a model that I can either change to fit my use case or one that will just fit my use case. So some great places to go get that are Prusa Printers, Thingiverse, and My Mini Factory. Those will have different those will have like 3MFs or STLs that you can just download for free. My Mini Factory, some models are available for purchase, which is not always ideal. And then you got GrabCAD, which is actually not only great for 3D printing, but just CAD in general. So it allows people to save their just the original CAD files to a website for everyone else to use and download, which is super nice when you need to if you have something like if you need a custom bracket, but it's not a widely available bracket, but it's got a use case that maybe someone already's made one. So some different CAD software. If you've never done any CAD before, I'd start with Tinkercad. It's basically just building blocks that you can change the dimensions of. It's super great, although you'll find that might become limiting very quickly. So for parametric design, so that's measurements and the CAD drawings and all that stuff. So that's like the stuff you'd use for FRC. So that'll be SolidWorks, Fusion, Inventor, 3D Experience, Onshape. Your team probably has your team would have a license for something that would cover this field. Once you've graduated or you no longer have access to that software, Fusion 360 is free. That's what I would use if you no longer have access to the software. If you wanted to emulate clay, there's some sculpting softwares like Sculpt GL. I've never used it. People say it's pretty good. If you want to make like figurines for like your tabletop RPG games, you'd want to use Blender. I've heard it has a little bit of a learning curve. I haven't played with it. I spend a lot more time with the parametric design softwares. So I don't have any experience, but I've seen and talked to people who have used it, and I've seen some tutorials go by that I've watched a little bit of, and it seems to be pretty easy to find tutorials for Blender. So what is a slicer actually? So a slicer is a piece of software that converts your 3D models into G-code so that the printer can actually print it. So G-code is just the programming language used by CNC machines that has since been adapted to 3D printing. more or less it just tells it to go to different coordinates and extrude along the way, basically. So some things the slicers can control is the layer height, the speed, the infill density and pattern, as well as support material, which I'll show in the tutorials for Cura and Prusa Slicer, as well as a lot more stuff. So every year, the slicer is able to do more and more. So like you have brims and stuff now, which again I'll show off in the Prusa Slicer demo. It's ultimately how you're going to take your part from a model on your computer to a real world object. All right, so what slicer should I use? So if you have, like anything, proprietary is probably the way to go. So if you have a MakerBot, use the MakerBot slicer. If you have a Prusa, use Prusa Slicer. If you have an Ultimaker, use Cura. Anything else, I would recommend Cura or Prusa Slicer. Prusa Slicer now supports a wide variety of third-party printers, as well as the capacity to create your own profiles, as does Cura. So if Prusa Slicer doesn't support your printer, Cura probably does. Cura's massive. It's probably the most widely used slicer. I'd put pretty good money on that. Although it depends on the printer you're using and the interface, if it works for you or not. All right, so how do I actually use a slicer? So I'm going to pull up Prusa Slicer here. And then I'll move on to Cura next. So here you can see Prusa Slicer. So I've got my print settings selected. So you see here there's different layer heights. This will affect both how long your print is, as well as theoretically how strong it is, although I'll get into that later and why that might, I'll get into that into the next presentation, how that might be important in particular use cases. But the difference between, like, if you look at 0.15 millimeter quality and 0.15 millimeter speed, they look very, very similar. And the speed is just like it says speed, it's a little bit faster. So I'm just going to select that. This model that I want to print is, I'm going to print it in PLA. It doesn't really matter what the brand is. So just here, generic PLA. I've got my Mark III selected. So I'm going to bring in a model. So you just click that. You can either go File, Import, and then you can open it. Or you can just click this box with a plus. You select your model. So here I've got a benchy boat. All slicers have the ability to move the models around as well as rotate them. So if you, for whatever reason, didn't want to print it 90 degrees, you could do that. Maybe you need to print it a little bit stronger. I'll get into more of that later. So I'm just going to use this as an example for support material. So you can see I've got supports here. So this is going to extrude extra material to, like it says, support the model, because 3D printers just can't print into thin air because the filament has nothing to stick to, as well as it just has, gravity will do its thing. So I can select support on build plate only, which, like it says, will only put support material on the build plate. I can select support enforcers only, which should only put them on the model itself, on the plastic, or everywhere, which will do both. So I'm just going to do everywhere here. Yes. So there are some things you can actually do. If I go into my printer settings here and I go to support material, so you can actually change the overhang threshold. So when your print isn't supported by the previous layer, there will be an angle with the build plate. And what this setting allows you to do is tell the printer, hey, I know that you can print up to this angle before prints start to fail. There are models online to test this kind of stuff with. They're super easy to find. So I'm just going to leave it at 55 degrees. So yeah, again, all this will do is just make sure that the model, that the supports are only where they need to be. So if you can print 76 degrees, for example, before it doesn't work. You could tell it that. That's your mileage may vary on the printer. Some of them do angles better than others. So I've got my supports turned on. I'm going to slice that. So this is just going to take a minute. And then you can see right here the support material. And then if I lower the height of the model so you can see better, there you can see the support material. So as you can see here, as the printer goes along, you see how it starts to print onto the material, on the support material, which helps keep it supported so it'll actually print. So some other things you can do with the slicer, so I'm just going to get rid of this here, is you can add a brim. So I'm just going to use this, so I select the part. This tool is called Place on Face. You just click it, and then the model will tell you, the software will tell you where the different flat spots that it can place the model on. You usually want to go for the biggest one, as that leads to usually the best adhesion. Now, again, I'll get into it later, but there may be reasons why you wouldn't want to do that. I'm going to hit this arrange tool. So if you have multiple parts, this will arrange them so that they'll print optimally. So now I'm going to turn on a brim, which basically makes it so the printer is less likely to warp, that the printer is less likely to warp or have elephant's foot. So what warping is when a part starts to curl and pull away from the build plate. I'll have some pictures for next time. I just wasn't able to find any parts that I had warping on. But basically it curls up. So that tends to lead to either parts that they usually don't print super well. They might still work. A brim will help prevent that, although you don't always need it, and you don't want to use it unless you need to, because it's wasted material, kind of like supports. You don't want to turn supports on for every model, because if you don't need them, it's a waste of plastic, and that costs a lot of money over time. So I'm going to slice it again. So now you can see that I've got this little brim on here. It's in green. So it's just one layer thick. So it's the green outline here. It's just one layer thick. It'll prevent the corners from, it would prevent the corners from curling, as well as potentially the edges. Although most slicers now have a compensation for elephant's foot you can turn on. And what elephant's foot is just warping, but instead of it being on a corner, it's on a flat edge. It's caused by the same thing. It's just, the print isn't sticking to the bed very well. Yeah, so that's brims. And then I'm just going to show how you could change the infill. So I'm going to go back here. So you can select your infill here. So I'm going to select, for fun, let's say 5% infill. And then maybe I don't want the infill that the slicer has pre-selected for me. So I'm going to go into my print settings. I'm going to go to the infill tab, and then you can select the fill pattern. In the next presentation, again, I'll show off the different fill patterns and why you may want one over the other for various reasons. So I'm just going to select honeycomb for fun. So I go back to the platter, which will bring me back to the build plate. I've selected 5% infill. I'm going to click slice now. It's going to slice the model. I'm going to go down here so you can kind of see it. So you can kind of see the infill. 5% may not be ideal, but all that red stuff on the inside, that's the infill. So that part is now 95% hollow, which makes saving filament super easy. Yeah, it's got a little, Prusa Slicer likes to put skirts here. Some slicers do, some slicers don't. That's just to make sure the nozzle is clean before it prints any layers, to prevent it from picking up the plastic again and failing. So yeah, that's pretty much slicers. They're pretty straightforward. for the most part. So I'll now jump over to Cura to show, just to basically show the same thing. Well, I won't show all the same settings. I'll just show basic print in Cura. So I select Cura. All right, so now you're in Cura. The one nice thing about Cura is that I still have my the same printer selected, and you can see that Cura actually tells you what, it shows you what the total build volume is, which is super, super nice. So that when you have parts in it, you can actually visualize how much of the build plate it takes up, which is something I wish Prusa Slicer did. So I've still got generic PLA selected. I could select different material. You can select your different, the different companies that make it. So I'm going to select some Polymaker PLA. I'm going to select the poly. I'm not actually going to. I'm just going to go generic. Let's do PTG this time. Okay, 1 second. I'm not going to do that. That gets into some other settings. So I'm just going to select PLA. So again, you can select your qualities. Cura actually allows you to type it in. You usually just there should be suggestions, or maybe there's not in Cura. I don't use a ton of Cura. I wouldn't, most printers, I wouldn't use anything over 0.3 millimeters. Oh, I forgot to talk about walls. So this will remind me to talk about walls. So if I import, so in Cura, you click the file folder, you select your model. All right, so now it's loaded my model in. It's the same benchy boat from before. So now so I'll slice it once here to show wall thickness. So I'm going to preview it. So everything that you can see there in green is a wall. Wait, nope, green is that same skirt. Everything you can see in red should be a wall. So I can change the wall thickness. So right now, if you were to measure those with a caliper, they should be about 0.8 millimeters. But to make it super drastic, I'll double it. So I'll make it 1.6 millimeters. It'll be the same. It'll be four extrusions thick. So the diameter of your nozzle will determine how many wall lines it has. So I'll slice it again here. And then you can see that, oh, maybe they were green. Oh, I did something. Whoops, my bad. So now you can see the green, I think actually is the wall. So you can see the green is a lot thicker than it was before. So that's just increasing the wall thickness. It's all these slicers do the same thing. They may call it something a little bit different, but it's all about the same. So I'm just going to go back to the 0.8, slice that one more time so you can see the difference. So you can see the green, it's just 2, one with the red, one with the green. That adds up to 2, just like the red and the green before added to 4. You can change your top and bottom infills. I don't mess with that a ton. It usually doesn't make a big difference. You can change your infill densities or your infill patterns. It has almost all the same options as Prusa Slicer. Material is just material. You can mess with the speeds and the cooling, and I'm not going to get into that because I haven't actually spent enough time messing with those settings to be sure of what I'm doing. There's lots of tutorials though that will explain how you can play with those settings. Is there anything else Cura does that's special? I don't think so, and I think that was all I wanted to talk about for slicers. Yeah, so I think that's it. So there'll be another one that I'll talk about how you do things to print everything, design and print parts so that they hold up under stress, whatever that stress may be. All right.